Hey folks, welcome. Hey, I can say welcome 1,000 times. I'm not going to, but we are so glad you've tuned in. We're back live. It's been a long time since back in May, so tune in. I'm Ernie Roberts. I'm your host for Mathline. We are back again. Kind of a new opening. Thank you, Esma, for doing that. And you know, we just got a great show for you today. But you know what makes it really great? You know what makes it rock? I hadn't changed. Is when you give us a call and we hear from you and we talk live. That's the whole idea. Give us a call. We've got operator waiting to stand and take care of you, and we'll pop you right in here. We'll solve some math problems together live on the air, and it doesn't cost you a cent. So tutors, yeah, you get them for other things, but today I've got them hopefully for the next 22 minutes, 30, 24 minutes, whatever, how much time we've got. We're going to play on it, and should we need some extra time afterwards, we'll talk with you on the phones afterwards, okay? But anyway, that number, I guess we need to tell you that, right? 844-686-2378. Most of you guys are back in school now, so let's hear from you, okay? And speaking of hearing from it, you know what it's time for? The first problem of the day. And today is one of those great things that's supposedly baffling the internet, dividing the internet, all sorts of descriptions about the internet with this problem. So here it is. Simplify the expression. It says 8 divided by 2, and then we got a parenthesis of 2 plus 2 hooked over to the 2 to one final number. And there have been all sorts of conflict and all sorts of stuff. So let's take a look and show you a little bit of that on the internet here. This is from the WBIR Channel 10 local station here in Knoxville. And they have it. It says the problem is dividing the internet. And over 1,300 comments. Goodness, 1,300 comments and also over 220 shares on this thing. It's crazy. So what is so big a deal about it? People love to figure out what's going on in the world of math, and some of these little things like here, well, you get more than one answer. Maybe, maybe not. Well, let's take a look at it, all right? Let's take it back here. And I'll tell you what, when we look and think along the way, what I hope that we will do is to get ourselves to the simplify expression here. We're going to channel the good old order of operations. Now, take what's going on here. There's the 8, there's our divided by 2, and in parentheses, we got 2 plus 2. Crazy, isn't it? And you say, well, Ernie, how many different answers could there be? Well, a lot of it depends on how you were taught to solve this problem way back in the school days or such. We're going to use, you got it, my dear Aunt Sally. And not only are we going to use my dear Aunt Sally, we're going to say please excuse because we've got a parenthesis. Now, for those of you who are wondering, what is the please excuse my dear Aunt Sally all that about? Well, please stands for the parentheses. Excuse, exponents. We don't have any exponents here, so we're not going to worry about that. My dear, MD, multiplication and division. And a lot of times people say, well, does that mean you multiply first before you divide? No, it means we're going to work those together. It's my dear. So she just works together as a whatever comes first. And then, last but not least, we'll add and subtract in the final outcome. In this case, it's going to all go to division and multiplication once we clear the parentheses, as most of you are seeing. Now, some of you are out there. I will really enjoy hearing some of your commentary if you're willing to call in about it today. Let us know what you think. After I work it one way, I'm going to show how the other way could be interpreted, and you decide which one you like best. Personally, I like the one that the calculator is probably going to give us, and we're going to check that one out also to see if we can get it to work back through. So patience with us all today as we work through this problem of the day. Have some fun with us. And parentheses, I did say please excuse, right? So let's go with 8 divided by 2. And I'm going to go ahead and change this parenthesis to a times because what we're going to do is we're going to make that become 4. Now, my dear Aunt Sally, some people say, well, you're supposed to multiply first, then you divide. Well, no, once again, that should be given the same equal precedent, equal treatment. In fact, what we're going to do in a minute, we're going to run it on the calculator, see what the calculator thinks we should do, all right, which is running like a computer type thing. So as we see here, work it left to right. So we're going to go here next. We're going to do division. It's going to give us a 4 times a 4. And I'm coming up with 16. Now, if we had gone another route, I think everybody's agreeable that we are going to put the parentheses out of the way first. If we'd gone here, and we put a little times there, what's going to happen there? Well, hold on a minute. We're not going to go to the computer yet. We're going to get there in just a second. Some of you are anxious to see what it's going to do, what it's going to do. I know. But let's suppose you decided to do the multiplication first because you always thought multiplication comes before division. And that would give us what? 8 divided by 8, which is a totally different answer. Now, as I say, most places are programmed. I'm really kind of curious to see how well this one works out because we're going to surprise ourselves, all right? But in this case, I'm looking for 16. Let's see what good old graphing calculator tells us. Let's go there, guys. We're going to take 8 and we're going to divide. And we're going to, let's see, we're going to clear again. Sorry, guys. There we go. Let's try now. 8, we'll put a divided by and put a 2. And we're going to put it just like it says there, parentheses, 2 plus 2. And we'll close them and see what it gives us. It gives us 16, all right? That's the way it's programmed. It's programmed to work it left to right like we did on our first job here. Now, once again, I challenge you guys. Let me know which way you think is, what turns your crank and which way you want to go with. If you want to give us some calls on that, we'd love to entertain that issue today also here on the show. And I hope our Facebook folks who got to see this thing in advance went for the 16. Some of you may have gone for the 1. We'll check those out tomorrow and see how the results come up, all right? But there you have a problem of the day. We saw what our calculator thinks. Now, what do you think? Give us a call, 844-686-2378. And also, give us a call. We're back live on the air. We're ready to work some math problems with you. We're all over. We've got Middle Tennessee, East Tennessee, Upper East Tennessee, Southeast Kentucky, Southern Middle Kentucky, Central Kentucky, I guess you call that. Also Western North Carolina and, of course, Southwestern Virginia. So we definitely want to hear from you this afternoon, my friends. We have a great show for you. But again, when you call and we talk, it's a lot more fun, makes the show rock. It really does. Now, speaking of which, many of you, I hope, have been tuning in with us during the summer this year as we've done a little Pythagorean theorem work and right triangle work and big stuff coming up on our specialized segments coming up for the weekend part, on Fridays. Yes, Friday's part of the weekend, isn't it, for a lot of us? We're going to be having some trig look, all right? Some of you have been asking for trig, getting some trigonometric functions, sine, cosine, and tangent. We're going to see that happening starting this Friday. So you don't want to miss out on those either. Tune in. A lot of you high schoolers and sometimes even your middle schoolers are kind of wondering, what's that S-I-N, C-O-S, and T-A-N on the calculator button? Well, tune in and find out. We're going to look at it on Friday. Now, let's take a look at another nice little problem going on here. And while we're hopefully going to have you guys call in, we'd love to hear from you today. You make the show rock. Remember that. We have Jill going out for a walk. Now, walking 30 feet north, 15 feet west. Then she decides to go a little bit more. She went meters. Well, let's just keep it off feet. How about that? All right, let's just go ahead and we're going to keep that on the same thing. Otherwise, we will be running ourselves crazy. All right, so let's keep it feet on that, if we will. And we have to correct ourselves, don't we? And how far away is she from her starting point? That would really be a lot more complicated. I have a feeling it's going to come out a lot nicer. Now, how far away is she from her starting point? In other words, straight line. We want one straight line. We don't want to bump it around or groove here, groove there. We want to make one nice straight line. And that'll be interesting, I bet. So let's try it here. Let's see. We're going to start her down here a little bit. We're going to go, we'll pick it up about right there. She's going to go 30. I'm going to give a guesstimate here. We're going to call that about 30. Okay. Then she goes 15 to the west. Oh my goodness. Maybe we should start her over here. Good start on this show today, isn't it, guys? All right, let's see here. All right, so we've gone north. That much we know. Let's go west. Not quite as much. About halfway as much, maybe. Here we'll take it west. And let's go north again. This time, 10, not quite as much. About right there. And then she ends up going west, 15, one more time. So let's see what that's going to leave for us. So we got 30 north and 10 north. So here's 30. Here's 10. We'll say this looks like 15. And this looks like 15. And what we want to do is figure out how far did she walk? Well, Not how far did she walk, but how far is she from her starting point. And by the way, these will be in feet also. All right. So we got 30 feet. And again, these are nice little right angles here. Some of you get ooh, you see right angles? Maybe you're going to make right triangles here. Not too little ones, because notice we didn't quite get to the point where we could connect here and then down to here. So what we're going to do, we're going to keep our 15. We'll keep our 10 there. That's good. And there's our 15. But we're going to fill in and make one big triangle, one big right triangle. There we go. And we'll pick up 10 here. By the way, these are feet. And over this way, we're going to put another 15. We're going to have feet also. And I'm seeing, question mark is, since we love that C as a hypotenuse, it's a right triangle, is it not, my friends? So let's pull it right in here, kick it around. And what do we got? We got an A squared, B squared, C squared situation. Well, how long did we go west? It looks like about 30. This way, we went 40 feet. And over here, we'll just work it out. We got A squared plus B squared equaling to C squared. Now, in looking at that problem, why did I do that? Because it's Pythagorean, right? Right triangle, Pythagorean theorem. Legs squared plus another leg squared, sum of them, equals the square of the hypotenuse. In this case, hypotenuse is C. So let's play it in there. Put the numbers we've got, and all we're looking for is C. Nothing magic, nothing hard, nothing difficult to have to do here. So let's put in our, how about it? 30. We'll square it there. And our 40. And we'll have C squared hanging out over there. Click through this thing. How about it? 30 times 30, we get 900. 40 times 40. You say, Ernie, how did you know that? I knew 3 times 3, adding 2 zeros, right? And here we go, 40 times 40, that's 4 times 4, 16. Add 2 zeros. And we're going to have a C squared moment there, all right? Now, where do we go from here? We've got to add. We've got to do some addition, right? So let's do it. We get 2,500 equaling to our C squared. And I think we need a square root. And it looks pretty similar to what we've been doing along the way here with the 900, the 1,600. Think about it. What is the square root of 25? And that's going to give us 5. Now, the question is, and some of you may be working this out at home, I hope you are, is it 50 or 500? Well, certainly 500 doesn't make much sense because we just went 40 and 30. That certainly can't be 500. So let's think of it being 50. But real quickly here, let me clear out on our calculator. Let's see what happens when we put in the square root of, some of you like to go there, I know, I do too, and 2,500 on there, because it's a large number, but the zeros do make it nice. And we should get 50, which we do. So we got a 50 coming out of there, and that, once again, that will be in 50 feet. There you have it, all right? So, easy problem, if you think about it. Draw a picture. Always draw a picture when you can, and that will help guide you where you're going, how you're getting there, and all those good things. So 50 feet, we have it there, all right? And hopefully you got that at home also. Now, once again, we need some calls. 844-686-2378. I feel like I want to be welcomed back a little bit, my friends out there, so give us some calls here, all right? 844-686-2378. I know school has just started back for some of you, but for many of you, it has long been going, right? It's good stuff there. So give us those calls, and we will be glad to work some problems live for you on the air. And even if you just want a little bit of review time, you got some of those summer review packets to work with. Hey, give us some calls, all right? 844-686-2378. This is Mathline. I'm Ernie Roberts, and I really do want to hear from you this afternoon. So let me do that. And we've got operators waiting to take good care of you. So let's look at our next little problem that we've got going on here. It says, determine whether 2/9 over plane fractions. So this is for your middle school folks, and some of you maybe even first-year algebra students there, pre-algebra gang, becomes a terminating or a repeating decimal. Ooh, those words. What is a terminating? Repeating sounds just like what it does. In other words, you put the decimal down, the 3, the 2, the 4, whatever, and it starts repeating, all right? Or you might have a 29 that repeats. In this case, that's not going to be the case, but it might be 29, 29, 29. And what do we do when we see those? We put a bar over them, all right? So when we look at this, you say, how do you know that, Ernie? Well, you say, you could punch the calculator, couldn't you? We could, but let's see what would happen if we were just to try to work it out, all right? Doing it good old short, I think it's short division because it's not going to take very long to figure this one out. So let's take our 9 and we're going to divide. What are you going to do? We're going to take the 2/9 and we're going to take 9 and divide it into 2. All right, so 9 goes into the 2. Right there we are. And you say, Ernie, that won't go. Could we not have done it 2 over 9? Well, we have it 2 over 9, but could we not put the 2 outside and the 9 on the inside? Because sometimes we think that's the way it's supposed to work. It's always supposed to be the larger number on the inside, but in this case, it's not the case. So let's play it, put a decimal right there, because remember, we're going to figure out whether this is a decimal that terminates. The way terminate means it has an ending. It does not ramble on and on. Sometimes you may think I do it. And that's why we want you to give us calls, all right? So put that 0 here because that's where we're going to go. That's where we're going to go. And if we divide 2 into 20, you're going like, it doesn't go evenly. Absolutely. So that tells me that we have not terminated, that's for sure. We may find a repeating. We're going to keep working at it and see what happens. So 2 times, isn't it? 9 times what number? Think of your multiplication facts. 2 times 9 gives us 18. I think 3 times 9 is going to take us way over the limit. So we got to go with 2 here. So we'll put that 2 right there because it's not about the 2, it's about 20. 2 times 9 gives us 18. Subtract out. Got a 2 again. That tells me something. Got a 0. Keep adding zeros. Now, and you say, Ernie, why can you add zeros? Because once I put that decimal here, 2 with 0.0 or 2.00, it's the same value. It has not changed. We're just using this to help us get to a final answer. Guess what? That zero's coming down and it sounds like we're doing the same thing over again. Absolutely. So it goes in there, what, 2 times? And we have the repeat. And again, if you want to go one more time to torture yourself, you don't want to torture yourself. Go have fun with it. You've got another 2 coming out. So look what's going on. We've got a repeating decimal. Where is the decimal point, by the way? It's going to move straight up. We put it straight up. There's no rationale to move it anywhere else. You just put it straight up because there's nothing to shift in from the 9, and life is good. So what we've got here then is, why not? Let's just put the repeating bar over the 2. So it is repeating. So we've got that aspect down. So now, here comes my real question to you. How do we go from actually this repeating decimal back to 2/9? And you say, well, it just works that way. Well, first of all, let's check something here. I always go to the calculator. You know I like to do that. Let's do 2 divided by 9. And they just kept repeating on and on. They ran out of room. That's why we have it running out, looks like about 10 decimal places. That does not mean it stopped there. It just means that's all that we had room for on the screen. It just keeps going on and on till the end of time, which gets kind of slow and old and dull. So if we go back to my picture, thank you guys, you see if I use 22, that's 22 over 100. And that's not going to get me back, I guarantee it's not going to get me back to 2/9. It's going to get me to probably 11 over 50 when it reduces, all right? So what we've got to do is come up with a nice little scheme to figure this out. And so it's going to be a real quick little arithmetic, pre-algebra type moment here, all right? What we're going to say is we're going to start with a number n, call it n, and we're going to put a decimal with a 2 and the repeating bar right there. And what we're going to do, we're going to move that decimal one place to the right. But we can't call it n if we move it one place to the right. We've got to call it 10n because we're multiplying by 10. But now we have 2 and the repeating decimal still hangs in there. So let's do a little subtracting, my friends. Let's go some subtracting. We get 9n equals, the repeating parts go away. Leave you with 2. And now divide both sides by 9. And look what we have. We went from the repeating decimal back to 2/9. And I think we have a call waiting for me. So welcome to Mathline, our new season, and we're glad to have you with us this afternoon. Who am I talking with?
Ernie!
Hey, who we got there? Is that Steve?
Yes.
Steve, good to hear from you. How are you doing? How was your summer?
Fine.
Very good, very good. What's going on in your world now?
I heard a rhyme on a show.
Oh, yes?
They had every good reason to fear him. He was a walking Pythagorean theorem.
I like that. I like that. And you know, that is such a, the Pythagorean theorem is so used. You know, it's a very practical thing. A lot of folks, Steve, don't realize that we measure diagonals by of TV by the hypotenuse of a right triangle. So,
Yeah.
and you know, they don't think about it. They think, I just go out and buy this big screen TV with a big diagonal number on it, and I know what's going on. And a lot of folks think that's how long they are, but it's not. That's a diagonal measure that gives you the TV length there. So if you ever try to measure it, it will come up quite short if you do the length of the width. So you got a good problem for me today, or something to think about here?
Yes.
You always do.
I wanted to do the plotting calculator.
Okay, yes, sir.
Okay, the period of a pendulum P.
All right. Give me the
Equals-
formula here. Give me a formula here on that.
P equals 2 pi
Okay, y equals 2 pi.
P. P, the period of the pendulum.
Okay, so 2 pi e. All right, so the e is
2
attached.
pi root, 2 pi root L over G.
Okay, all right. So
No, you got it wrong.
I've got it wrong. Okay, try me again on this. What's your formula again?
2 pi root.
So y equals 2 pi
And
times
then root.
the root. Okay. Okay, we got it?
L, the length of the pendulum,
Okay.
over G.
Over g. What do our variables stand for here?
G is 32.2.
Is that gravitational moment or something? Okay. 32
And
point.
then L is length.
And your L
and
is going to be
feet.
a variable length then, right?
Yeah, feet. So I thought maybe you could do it in increments and have the calculator
Okay.
plot it for the period Y.
Right. And what I'm thinking is, Steve, we're gonna wonder here, and we may be caught in the middle of the thing, but let's go to mode here. I think, and I'm trying to think, we may want to put this thing into radian mode instead of degrees. I have to think that's, and you know, I'm not the physics major here, but I'm thinking that formula may want us to use radians. So I'm going to go there, and then let's see, I'm going to let the L be X, all right? Because that's basically what we're trying to find out. That's our variable that's changing, right? That's our explanatory variable. So,
Yeah.
so let's go to the y equals here, see what happens. We're having fun here on Mathline. We see what goes on. I'm going to hit 2 pi. Oh, wait a minute. Yeah, that's right. 2 pi, right? And let me find it. There we go. Right above, right there. I just reddened it up for those of you who are still watching us here. Second goes to the square root. And then we'll put an x. And I think I want a quantity. We'll get that in there. X. And we're going to divide it by 32.2, right?
Yeah.
Divided by 32.2. So all that is under the radical. And let's see what our graphing calculator is going to do. We may have to work on the window a little bit here, but we'll start here and see where it goes. There you go. It looks like it's just kind of shooting off there at 0. Obviously, there would be no value, correct?
Right.
And if you'll notice what's going on here, back this way, what's going on here is simply it can't happen because we would have a negative square root and we'd have imaginary numbers. So that's the first thing we've got happening here. It looks like if we hit a trace on this, there's my trace. And if I were to go, let's say I was going to go for a length of 6. Press it and see where it takes us. It looks like it takes us to about whatever I don't know what our measurement of this thing is in, but this obviously is not what we wanted. At the top there, I'm going back to what we rewrote. It's our formula. So your length is going to be a variable in there, and it looks like as you plug in those numbers, that's where it's going. And I'm using the radians there because I think the degrees would put it way out of whack. Okay? Does that make sense?
Yes.
All right. Well, thank you for getting us initiated back on track today here, all right? And that's why I like the graphing calculator, because it gives me a picture of something, and I'm going like, I'm not sure what we're going to see. But that is typically what your square root curve looks like, folks. So multiplying by 2 pi, it's a nice constant there. So
it's
Steve?
half of a parabola.
Yeah, because, that's really what's going on there. It's a nice little curve. And if we'd put a negative 2 pi for whatever, that would take us down under. Okay? All right.
I called it in last year, but I got the formula wrong.
Okay. Does that help a little?
Yes. Thanks.
Super. All right. Folks, there we go. We're back. We want to hear from you tomorrow. Make your plans to be with us again. Thanks for tuning in, and we'll see you then.